Hello friends, welcome to the fourth video of the quiz. Here we will talk about the data preparation phase to model the data. Here we have basically the five topics. The first one will be how to split the data into training and test data sets. Second will be how to how to balance the data sets. Third will be the how to build a decision tree using algorithm CART model. Fourth will be the research C 5.0 and the fifth will be the random forest algorithm. So first of all, we start with the splitting data into training and a testing set. It is one of the important phase in which we divide the data into training and testing set. In the we divide the training and testing set uh, to train the model and test the accuracy of the model. Here are some criteria in which we divide the data into training and test set. First of all, it may be have 75% of a training set data and the 25% will be the testing set. Here we in the Python we use the train test split function which is available in the sklearn.model selector which will be used for dividing the test and a training data sets. Here we have a data frame having some features and a target variable is the target variable here name is column name is target. So here we can see that we have a divide the data into the x and a y. So with the function of a train test split, we divide the x train, x test, y train, and y test. Here we have x and a y, which has the value given above, and we have the test set size equals 0.2, which gives that 20% of the data will be for the test set. So here is its output. So we can see here that the 80% of a data contains the training set and 20% of a data contains the testing set. So here is the way we can split the data into a training and a test set. So the next is the how balancing the data for a model. So what's mean by the training the data for a model? Sometimes it may happen that we can generate unbalanced data which can bias into the one target variable. For that we use the for that we balance the data using the SMOT method in which is present in the many functions. Here we use the IMB IMB run dot over sampling method package for using that. So here is its code and output. So we can use the SMOT method and we create the data which will be balanced for training model. So we can see that the training model is changed so that for that in that training model 0 has the more number than a 1. So here 0 and a 1 both have and target value of a count of a 2. So it's the way how we can balance the data sets. Third topic is the constructional CATE decision tree. CATE full form is the classification and regression tree, which is the based on the Gini index. Here we use the criteria Gini as for dividing the model. So it is the way in which we create a CATE decision tree. So here is example with the help of that we use the Gini index. For that we can see that it's give the many example how can we create a decision tree using the cat classifier. So the next is the constructing the C 5.0 decision tree. C 5.0 decision tree is the improved version of CAT decision tree. Here, normally Python does not support the C 5.0. We can create it with the help of entropy. So it's the output of of a C5.0 decision tree, we can see that there is not so much difference in both of that, but there are some of that which can improve it the decision tree before that one. So the next is that constructing a random forest decision tree. Constructing a random forest tree is the best example in decision tree. It creates the multiple decision tree and finalize the best and create or finalize the or create a best decision tree from all of the before created decision tree. So that's why it's has the maximum number of accuracy. So here we have a we separate classifier for random forest we can which is the imported from the sklearn ensemble. So here it's we use the constructor of random forest classifier and train that data according to the x train balance and x train y, which will get from the second subtopic, which is the balancing the data set. So here we can get that we have created the sklearn.ensemble import random forest classifier. We have the estimate of 100, and we can that it has the good uh, features. So that's for the random forest classifier. So thank you for your attention. I hope you understand well. Thank you.